Hello there. In this next set of videos, I will be recording short 10 to 20 minutes of lecture videos that are describing or discussing some of the topics in linear algebra for machine learning, particularly designed to be as a supplement for my course that I offer at University of Chicago Data Science Institute. And this course is actually designed for those who would like to pursue careers in machine learning and data science and advanced deep learning AI, and who are not very comfortable with linear algebra topics. So here we go. As I mentioned, so this is going to be a whole lecture series that I will be giving in the University of Chicago, but I'm changing the style a little bit from in-person or Zoom lectures that take 3 hours and then followed by Q&A. Instead, I will be uploading the most boring part. I shouldn't call it boring, but the meaty part of the lectures that are going through the theory, explaining the theory, and going over some examples of what is needed for machine learning parts in the linear algebra. And then during our lectures, we will meet and directly discuss the topics that I cover in the lectures and some more, right? I will have, of course, some more material that I will cover in the lectures. And of course, as you see here, it'll be more dialogue kind of lecture, so it'll be more personal. You can ask more questions directly related or unrelated to the topic, or if there is something that you did not get from the lectures. I believe this gives some opportunity for, like, if you're bored of some lecture, some part of the lecture you can skip, and if you are not, or watch it 1.5x, sometimes I do, and if you do not get some part of the things, you can watch it again and have it forever. So I thought that this would be helpful for many people. But first, as I mentioned, I will record very short videos that are covering only part of the problem, and I wanted to start with discussing why should I learn linear algebra for machine learning? Because when you look at it, AI, machine learning, it's all exciting things going on. It might look like it's someone can try to sell you modern AI is a kind of skill that you can get through a set of workshops and apply certain things and then become an expert. But unfortunately, that's not the case. To be proficient in machine learning, you need to have some certain skill set. Not the skill set as in toolkits, but skills in math. One of them is linear algebra, and I will answer why in a second. Probability, algorithms. There are certain things that you need to be very good at, and linear algebra is essential to start an education in machine learning, in my opinion, because of several reasons. The first of which is it is the language of machine learning. So if you open up any of the leading papers today or reports, I included DeepSeek here, the most state-of-the-art techniques, they are discussed, they are conveyed with a notation that are in linear algebra. So like this capital letters that you see, for those of you who feel that are not strong in linear algebra, these capital letters they're representing matrices here. The lowercase letters are representing vectors, and they will be, as I will discuss in a second, they are representing data, as we know. So like there are certain operations like these subscripts, superscripts, they all correspond to something, and in order to understand these papers, these methodologies, it's essential to have an understanding of the certain operations in linear algebra. The good news is like it's not infinite, like you can have a good understanding by the end of this lecture series. As I mentioned, the second part is the data. Like the data science, machine learning does not happen without data, so we are trying to understand the world around us, and the data is represented as vectors and matrices. What is data? Data can be given to you as a CSV file, a bunch of rows, and or letters, right, as the modern natural language processing systems do, such as ChatGPT or any kind of generative AI, or audio, speech recognition systems, or images. So they are, in theory, like they can be in any form. When we are taking them to our computers to process, we convert them into vectors, a bunch of numbers, and these vectors are used as input to our black box. I'm not going to go into the black box here particularly. I put down some logo to represent that it is the AI, certain operations, which, by the way, are mostly linear algebra operations, and the output, whatever it is. If you're classifying, answering, regressing, whatever, or recognizing, so your output is going to be in some part of some sort of vectoral format or matrix, which takes vectors and matrices as inputs. The third approach, the third reason why you should learn good linear algebra is, as I mentioned, it is the language. It is it is the language of deep learning, but it is not only the language. It is not only the way that people present their ideas and methodologies. It is core to the methods in deep learning. So in this slide you see a few pictures. The leftmost one is one of the most famous ones. It's called the block diagram of a transformer. So if you zoom into this picture, you see there are some terms called input embedding, and multi-head attention, and feed forward. And you see this, there's this purple one here that says linear, right? Like most of these operations, the blue one is feed forward again. Most of these operations are matrix multiplications, right? Or selections, vector selections. So like the scale dot product, again, a picture, a figure from that paper, which changed the world that we know. Like it's one of the most impactful methodologies that are presented recently, which is the scale dot product, the attention, right? And the concatenations and all, etc., and low rank approximation. So this figure here shows, in theory, very simply, in a simple way, how to train otherwise very big size large language models without using so much of memory. Like, can you still do something to train? And the answer is what is shortly called LoRA, low rank approximation. You might not know what rank would correspond to, but by the in this lecture series you will learn what rank is. So that was the third reason. The fourth reason is from practicality perspective. So our hardware uses our hardware likes to use matrix operations, linear algebra operations. Let me simplify one thing for you. Let me demystify something for you. Linear algebra operations, when I call linear algebra operations, boils down to two very simple operations: addition and multiplication. Multiplying two scalars, add two scalars. Why does this matter? I will go into like how they will all correspond to what operations in linear algebra, how they end up doing all the things that are fancy today. But you see, let me cover this part of the reasoning. You see two things here. On the left, you see two PhD students that are capable of doing several experiments. And I can call that as a CPU. You see the CPU logo below that. So a CPU is like, you can take it as a PhD student. It takes something, it can calculate the logarithm of it, maximum of it, or exponential, Fourier transform, whatever, you name it. On the other hand, a GPU, which is, some of you might be aware, is the main hardware that is used to do large-scale deep learning today. Many data centers are being established with hundreds and thousands of them. I guess XAI in Memphis is aiming to do 1 million of GPUs. So a GPU, you can see a GPU is 1,000, maybe more, elementary school students. These elementary school students can work in parallel, but they can do only two things. They know with very high accuracy they can multiply two numbers and they can add two numbers. And if you can distribute the problem into little chunks of additions and multiplications, your army of elementary school students, 1,000 elementary school students, can do a very good job. And if they can give you your, if they can give back the results to you, you can compile, and then you can actually have an answer that comes faster than your two PhD students. Why did I give this example? The matrix multiplication is something perfect for our army of 1,000 elementary school students. And guess what? Linear algebra is all about matrix multiplications. Computer graphics is all about matrix multiplications. That's why the main AI hardware somehow weirdly called GPU, graphics processing unit. But if we have time, we can go into that. But I would like to conclude with the fifth important part. When you are at the end of this process, this program, you will go into interview. Some of you will want to go higher in your companies, or some of you will interview for deep learning scientist or engineer jobs. And for the interview and for the job, you will be required to know basics of linear algebra, especially if you are a scientist. If you would like to pick the path of an AI scientist job as opposed to an AI engineer. But I can assure you, AI engineer jobs also require you to have a good understanding of linear algebra. So let this be the end of this video. In the following videos we will go into what these topics are.